the same. Only the names will change every day. It seems we're wasting away. Another place where the faces are so cold. We drive all night just to get back home. I'm a cowboy on a steel horse I ride. I want it dead or alive. Want it dead or alive. Hey, what's up, you guys? Mr. Flugum here, and like we talked about in some of our Zoom meetings and stuff, I'm going to cover acids and bases with you guys. Even though we're post AP exam, this will be kind of stuff that I don't know that I would expect you to be familiar with or know after taking AP chemistry. So today we're just going to do this. We actually are not going to do the strength of acids and bases here. We're just going to cover defining acids and bases and conjugate pairs. Okay, so that's the plan. By the way, I'm really proud of you guys. Thanks for doing the AP exam, and no matter what your score is, understand that taking AP chemistry and going through the exam is an accomplishment in itself. So, all right, here we go. So first thing here, you guys, just some common things about acids and bases, and a lot of this is stuff you're familiar with, right? Acids are sour in taste. Think of vinegar and lemon juice, right? Bases tend to be bitter. So a lot of plants have bitter tastes to them, okay, especially vegetables and stuff. We tend to reject this flavor, right? And one thing that makes me think of a bitter taste is like a cucumber that's not good, right? That is bitter, and we tend to really not like that at all. Okay, so characteristics of acids, you guys, right? Remember, they react strongly with metals. We use them in tons of production and industrial applications, We use them for cleaning stuff, food processing, right? They're used in all kinds of foods, manufacturing explosives. Almost everything that we use, and any kind of raw material, guys, probably has had an acid somewhere in its production. Our stomach produces hydrochloric acid. Yes, that's the HCl that we all know and love, okay, to help aid in digestion. All right, let's talk bases here real quick. Okay, they feel slippery, all right? Think soap and detergent, okay? Lots of cleaning products, you can see them over here, okay? Our blood is slightly basic, okay? We have a pH in our blood of about 7.4, and most of them contain hydroxide, although we're gonna kind of bust that myth today, okay? So, what I taught you last year in Gen Chem is this, about acids and bases. It's called the Arrhenius definition of acids and bases. And it's the simplest. There's actually 3 different definitions in chemistry for acids and bases. This is the simplest. Okay, acids make hydrogen ions in solution, bases make hydroxide. Okay, so yeah, but there's some problems with that. Okay, first problem is this. It's only true for bases that have hydroxide ions, OH-. So there's lots of bases that do not have OH- hydroxide ions in their solution, but they make the solution basic. One example of this would be baking soda, which you may have noticed on the last slide with or 2 slides ago with bases, right? Okay, this is actually a basic compound, right? But it does not have hydroxide in it. In fact, if you look at it, you see the H and you might think it's an acid, okay, but it's not. And one of the things we'll learn as we go through this unit is how is baking soda a base? It's also, though, the problem with Arrhenius is it's only true when we have an aqueous solution. What happens when we don't have an aqueous solution, when we are maybe mixing dry solids together or something like that? So Arrhenius has issues. So what are we going to use? Well, we're going to use this here. It's called the Bronsted-Lowry definition of bases. Okay, and it makes it a little bit more general. So acids are proton donators, right? Okay, that's the same as Arrhenius. The difference is this: bases are proton acceptors. So that means that they will take They will take protons from things. Okay, now this is a more versatile definition of acids and bases, and this is what we're going to use here in AP Chemistry. All right, now this is going to be a big emphasis today, is these Bronsted-Lowry reactions where we have an acid, that would be this right here, a base, okay, and then on this side we have the resulting conjugates. So we will talk about that. So the first thing is this, right? We have our acid right here, and basically it donates a proton, right? So it gets rid of a proton here, that H, okay? And we have a base. That base, right, is going to deal with that. Well, we'll deal with that in a second, sorry. Here we have the acid, it donates a proton and it becomes a conjugate. This is called the conjugate base over here. So the acid results in a conjugate base. On the other hand, we have the base, right, which accepts the proton, okay, that is donated, and this becomes a conjugate acid. So I'll explain that a little bit more here on the next slide, but basically this is an equilibrium, right, you guys? So that means it can go this way, right, where we have an acid that forms a conjugate base by donating a proton. But then when we're on this side, if we're going to go back, this is actually the acid here because it is the proton donator, right? And this is a base, and this is a base because it is the proton acceptor when we go in the reverse direction. Whew, that's tough to understand. I know students in the past have kind of had trouble with that. Okay, so let's do a couple examples here, you guys. So what is what here? So here we have HNO2, this is nitrous acid, right? And here we have some water, and then we have our resulting ions, right, from this reaction. So if we look at this, here's our acid, right? That's obvious, HNO2. That's going to be our proton donator. That means if this is the acid, what's the H2O got to be, you guys? Ooh, if you said base, that's right. Okay. Yeah, because water can actually be a base in this case, right? Because it's going to be the proton acceptor from the acid, right? Now, if we look on the other side here, once this H falls off, we get NO2, right? We get the nitrite ion. That is called your conjugate base, okay? Because it's the resulting ion from your acid, okay? And then we get this. Our water accepts the proton and becomes hydronium, our conjugate acid, okay? Now the reason we call these conjugate base and conjugate acid is because in the reverse direction, right? Here's the acid, here's the base, okay? All right, let's look at one that's a little bit different down here at the bottom, NH3, ammonium, and water. Okay, this one's going to be a little different. If we look at these two here, which one's going to donate a proton? Well, if you said NH3, you were wrong because the acid is actually the water in this case. Weird, water can be an acid or a base, huh? Okay, but if we look at the resulting conjugates over here, we can see the water lost a proton and became the hydroxide over here, right? And the ammonium gained a proton, gained a hydrogen, and became the ammonia. So there's our conjugate base, right? Ooh, that is wrong. These are backwards here, you guys. So these should actually be reversed. Let me correct that. Holy moly. Okay, this should be over here, right? So reverse those. The NH4 is actually your conjugate acid because it comes from the base, right? And the OH minus is actually your conjugate base because it comes from the acid. All right. Boy, that doesn't help when I confuse things like that. Okay. So to summarize this, you guys, here is the deal. The derivative of an acid is a conjugate base. Okay, so there's our acid, right? What's the derivative of that? What comes from it? There's your conjugate base is the Cl, right? Now this would be your proton acceptor, right? That's why it's a base. This is a proton donator. That's why it's an acid. But these are conjugates of each other, right? And here's the deal. The derivative of a base is a conjugate acid. So there's our base, which is water. There's our acid, which is hydronium over here, which stems from the base, right? And it is a proton donator, so we must refer to it as an acid. Okay. So I have a short assignment for you guys, okay, to go along with this on acids and bases. It's fairly short, so I don't expect you to be spending long hours studying this and spending lots of time. But if you do it and turn it in, I think it would be valuable and help you understand a little bit more about chemistry and acids and bases. If you have questions about this, please let me know. Okay, I'll be happy to answer questions, dialogue with you on email or the comments, or we can even schedule a Zoom meeting. All right. Hope all is well, you guys. We got less than 3 weeks of school left, man. So hang in there. Take care, you guys, and we'll talk to you later. Bye-bye.